Hello everyone, welcome to my YouTube channel Data Partnership. So today video is for urban flooding, especially for uh, one of the city near Delhi. It's called Gurugram. Everybody knows about it, right? So last 20 year or more than 20 years, there are a lot of expansion happened and a lot of built up and a lot of infrastructure in place. And every year during the rainfall, so city got flooded in some areas, right? So it happens actually because wherever the development will happen, initially it will create some problem, but slowly, when we understand the landscape or understand the situations or in real time, then we improve it, right? So we cannot do everything before, right? So especially for developing country. So So I tried to show or to create a model, or you can say to understand the urban flood assessment of this Gurgaon city, right? So this is the Gurgaon one. So I have, you can say this is my study area. So so that's why. So what I did is that this is my AOI. AOI is this one, right? This is my AOI, area of interest. Then what we need is we need DM, digital elevation model, to understand the slope to understand the slope or elevation, right? So higher elevation will have lower risk, and low lying area will have higher risk. This is the general level. Then we will have slope. If we have steep slope, then we will have uh, and then water accumulates in flatter terrain. We know that if slope is steep, then water will flow. Um, So what we need to do is that this type of thing we have I have done earlier also, but because this is important for because we cannot say this area will be flooded by using only one parameter. That's why we have using slope and this is a I have built up area. So this is a built up area code. This is a dynamic word data. So we have I have used this. So filter bounds is AOI and data is from this one. So so then we will have from this, we will have, so actually we can, I will show you, this is the result actually. So this is the built up actually in the in Gurgaon area from this dynamic word. So where built up is equal to DW means this variable and then equal to 6 and rename I have built up. So you can put 5 also, but I have this is the general thing. So 6. So then I have added this in here in the in this frame, right? So now next thing would be rainfall. So how rainfall? Because without rainfall, we cannot say that this area will be flooded, especially in the urban areas, right? There is no river nearby. So rainfall is I have using chips data. So a lot of videos I have created. Please go through them. So this is the for the same year where we have used the data. Listen, then we will have the flow accumulation. So flow accumulation, I did not uh, do it from this DM. DM I have used for slope. This is I have taken from the hydroset. This is the open source data. You can check over there. This is the WWF data. So I have directly, so Google Earth Engine have this facility. That's why it is very good platform. So a lot of cloud data is there. So flow accumulation is also required because we need to understand where flow is accumulating in a certain area. The next step will be the normalized variables. So we have slope, flow, accumulation, rainfall, built up. So we have normalized. So I have normalized it, right? Then so now we have to based on these factors, what will be the flood risk? So we are using all these normalized factors like slope, normally multiply by -1, add +1, right? We are taking the absolute value to multiply by this. So this is the flood risk thing. You can check uh, in many documents or many papers. There are different values, but I'm just using this is my learning thing. So you this is not the actual one, right? Of course, area is actual one, data is actual, but these values differs, right, from area to area. So after this flood risk, we have to classify that how it is happening. Means we have to give the values, right? What are the classes one or two, right? If flood risk is less than 0.33, right? From this, like what we are using is slow or slow flow accumulation buildings, right? Then one where flood risk is greater than is 0.33 is values then we will have much more risk of flood. Then three will be more. So high risk zone is that risk class from this risk class equal to 3. Basically, this class 3. So then it will have more uh, flood risk issues, right? So so after that, so this is what I wanted to show you. So once you run it, then you will have these things, right? So you can say this is our built up, right? So built up I have, you can see here I will have this built up is here from the dynamic world I have taken. So you can see here this is built up, so I have added here. So that's why if this built up, then I will have this dm, right? So this is my dm. I have dm is this one, right? So E dot image, and I have selected this one and then click to AOI. So here I will, so this is DM, and then slope from the DM. So you can see this is the slope from the DM. So if you click here, then you will understand how it is happening. Suppose this red areas, right? It will take some time to suppose this red one. Yeah. Anywhere you can click here. Suppose this one. If you click here, then it will show you the slope. Slope is 21 degree. Yeah. And somewhere is, slope is less, right? Here is 1.0 like that. So similarly, I will have rainfall. You see, so after running this, so you can see we have this grid, right? If you click here, grid in this grid, then you can see we have 897, and this is the average one, right? So similarly for the flow accumulation, this kind of, and the means flow is coming to this way, right? And then the flood risk index. So this is, I told you that this is from the 1 to 3, right? So so 0 to 0 to 3, this one. If you click here, then you will see this will come now 0 point something, right? So if you this one high risk flood map, then you can see this is actually yeah. So I can put this above. I don't know how to do this, and if you put above this one flood risk map, I can show you. Yes, you can see here. So this is the area where these are the high risk areas. If you see here, so you can check built up is more, right? And you can see slope is, this is more flatter area. You see this one is more flatter. You can see here. I will show you how to, right? You can see if you click here, then you can check the slope as well, right? In this area, so slope will be more flat, okay, or right. And uh, actually it takes time to, yeah, you can see here. So if I just click here, then you can see slope will be 4 point something, means this area, because sometime you will find that slope is also less. So we assume that, okay, this, if flatter area is there, then more chances of flat. But that's why I added more parameter. It on not only in the slope. Slope is one of the major factor, but rainfall is also there. And flow accumulation, and lot of things we need to consider. That's why, then we have to, for this, what we need is, we need historical flood events, so that we can verify it whether it is happening or not. So how to do that? Because to get this flood extent or those locations from the government department, it's very tough actually, and it's very challenging to get that. So my next video will be the how to I will use synthetic aperture radar SAR image to get a training class. Suppose I want to predict the storm, the floods in future. So how to do that? So for that we need a training classes. So I will show you how to do that, how to conduct that from the synthetic aperture radar. So my next video will be that, so that it will help you to do a study in your area. So I hope this will helpful for you. It looks this Google Earth Engine's codes are very, doesn't look good actually, but if you practice it from the beginning, step by step, then it is wonderful, right? You can use and you can apply and you can lot of things. So in future, what I am trying to I will do is that I will use Python and in Python and other tools to conduct these kind of things, so that nowadays people are talking about AI and machine learning. So I will do that outside this Google Earth engine. So stay with me. So you will have a lot of good videos, learning videos in future. Thank you very much.